Good morning, good afternoon, or good night, depends upon where you are in the world, and I truly mean where you are in the world. My name is Bill Gustin. Welcome to this month's Humpday Operations Hangout. Where we are in the world, because this is truly going to be a special edition. We have participants from Australia, down under. I want you to know it's about 3 or 4 o'clock in their morning. They're wearing job shirts because it's the middle of their winter time. I wish it was the middle of my winter time here in South Florida, but this is going to be a special edition. I want to begin by thanking our sponsor. That's Key Hose. That's keyfire.com. Again, a very easy endorsement for me because that is the hose that my department buys and my company uses, so I have my hands on it every day. I relieved the B shift on a fire involving 2 mobile homes the previous shift where I was working, and that key hose was dragged through a minefield of hot metal surfaces and molten aluminum, and it held up quite well. Key has a remarkable mix or balance of flow capabilities. We're looking at friction losses of about 25 psi at 185 gallons a minute. It has remarkable kink resistance, abrasion resistance, and thermal resistance, as you can tell from the, or has been documented in a previous edition in fire engineering in the tests conducted by alcohol, tobacco, firearms, and explosives. I also want to give a shout out to 2 of my dear friends. First of all, Mike Galliano. Mike, you came on your own time, in your own dime, to Miami, Florida, to our Miami-Dade Fire Rescue Safety Stand Down, and gave a remarkable class on the firefighter air replenishment system, which is basically an air standpipe, and your namesake, your trademark class, the art of go and no-go. It was very well received. By far, you are the furthest guest that we've ever had. And we really, really appreciate you. And I think you can tell that you were very well received by Miami-Dade Fire Rescue. And I hope you got a little taste of that hot, sweaty Miami weather that you definitely do not experience in the Northwest. Another group of folks that I want to thank, and this is selfishly me talking on behalf of my department, is Mr. Robin Collier and Mr. Adam Crowell was from Sprinkler-Matic, who for our safety stand down, which was our safety-oriented conference, piped in a diesel-powered fire pump into our 7-story training tower and conducted a number of fire pump, standpipe, and sprinkler system classes that were absolutely outstanding and very well received. And I would be remiss if I didn't give them a shout out. Last person I want to shout out to is my dear friend, Chief Foy Jenkins of the Morrisville, North Carolina Fire Department. Foy, we listened to the recording of a worker that you fellas had. I guess it was yesterday or last night. Sounded to me like it was a well-involved fire in the cockloft or attic of a row of townhouses. Your guys got in there, aggressively got into the Charlie and Delta, or Bravo and Delta exposures, got that ceiling down and made quick work of the horizontal extension, the lateral extension into that attic. So shout out to my dear friend Foy, and we're looking forward to coming up for your badge pinning ceremony next week or the week after. Okay, enough, a little bit more about me. 39-year veteran of the Miami-Dade Fire Department. I began my fire service career in the Chicago area, and I'm a lifelong student of the fire service. So I'm going to introduce my friend would be to my left. It might be my right, depending upon how you look at the camera. Reick Owen, would you introduce yourself? Tell us where you're from and a little bit about your involvement in the fire service.
Oh, g'day, Bill. My name's Reick Owen. I'm from Melbourne, Australia. I'm a 4th generation firefighter, and I've actually got 2 brothers in the job at the moment. And at the moment, I've had 31 years in the job. and again, like you, a lifelong student, and love what I do. How's that for a start? Do you want a bit more?
Rick, how many times have you been to FDIC?
3 times now, but I've been to your beautiful country 7 times.
And Rick has also ridden extensively. Would you tell us about some of the American fire departments that you've visited and ridden?
Oh, yeah. In 2012, I was lucky. I had 26 days in the States. I went to LA County, Phoenix, down with you, into Miami, into Fairfax, back across to Oakland, San Francisco, Alameda. Yeah, been around a little bit.
At the risk of embarrassing you with compliments, Rick, if there's ever been a student of the fire service, it's you, brother. What a commitment. You have to understand, he's coming on his own time and his own dime when he's coming to FDIC. Now, if you think it might be an expense and a hassle to travel across the country, can you imagine that? Could you tell us, Rick, how long does it take you, total flying time, to get from Australia to Indianapolis, Indiana for FDIC?
On average, about 21 hours. So, yeah, it's about 15 and a half hours into LA, and then about 5.5, 6 hours from LA to Indy, depending how you go. Sometimes you go through Dallas, but generally lately I've got a direct flight, so it's about 5.5 hours. So, yeah, flying's easy. Flying's easy.
Rick,
Still, he's the same.
Could I ask you this, Rick?
Yeah.
Rick, could I ask you this? I'm going to drink, let me drink this Coke here.
Yep.
Yeah,
Try and colour for Coke.
Yeah, I'm going to drink this Coke. I keep it in this cooler. It's a nice cooler.
Yeah.
I got this. I had to send for it. It's my favorite football team, the Brisbane Lions. Are you familiar with them? I understand you're quite a big fan, Rick. Is that correct?
Yeah, I'm a fan of them. They're probably my second favourite team.
Oh, really? Really?
Yeah.
Oh, yeah. Well, you guys call it football. I call it soccer. But here's a shout out to.
That's a man's game. That's a man's game. The only padding they wear is a mouth guard.
Folks, that's a private joke. It's a private joke. Our next guest sent this to me, and I understand that Rick and our next fella from Australia are arch enemies when it comes to soccer or football teams. So here's to the Brisbane Lions. Okay, our next fella would be the other fella from Australia, from down under. Phil, would you introduce yourself, sir?
How you doing, guys? My name's Phil. I live in Queensland. That's the top part of Australia. I've been a firefighter for 22 years, and I'm a rescue guy, so sorry about that, Cap. But yeah, 22 years. I'm an officer at a rescue station, and riding the trucks at the moment. That's where I want to be. But yeah, been at FDIC 5 times now. Yeah, and it's a pleasure every time. Absolutely.
I wish, Phil, that you guys would have some type of Australian Google Hangout. Paybacks would be hell, because you could get Mike Dugan and I out of the rack at 3 o'clock in the morning. And then if you had like an Australian FDIC, Mike and I would have to take a road trip and go over there and reciprocate. But I got to tell you, man, both Rick and Phil, the commitment that you have in the fire service is reflected in your trips to FDIC on your own time is absolutely remarkable. And it says volumes about your dedication to our profession. Captain Dugan, sir, I see your mustache is growing back quite nicely, sir. Could you introduce yourself?
Yes, my name is Mike Dugan. I'm a retired captain from the FDNY. I've been to FDIC 27 times. No, more than something like that. But yes, I'm lucky enough to teach there. I am on the advisory board, the editorial advisory board for FDIC and Fire Engineering Magazine. As a matter of fact, right now, I am reviewing classes for the 2018 FDIC. I'm about halfway through. I've only done about 80 so far. But it's interesting, it's fun, and I get to do this with Bill once a month, so we do have a lot of fun, and I think this is going to be very interesting because the whole idea of what we're going to be talking about brings to light some of the differences and some of the similarities in the fire service worldwide.
Okay, thank you, Mike. Oh, before I say, hey, a big shout out to the FDNY. That rescue in a 200-foot deep elevator shaft that your fellas performed the other day, and it looked like some type of 3-to-1 haul system. I can only imagine how much rope, if it's 3-to-1 or 4-to-1. Absolutely amazing. If you haven't seen it, I don't know if it's on YouTube, but you could tell it wasn't the first time these guys did it. I'm sure they practiced it extensively. But you got every reason to be very proud of your job, Captain Mike. That was very, very impressive.
And the amazing thing about that, Bill, is there were 4 people down there. They got all 4. They had to go down 4 times.
You guys are amazing. Your guys are amazing. Our next guest is a very distinguished gentleman that I had the honor of having. He sat in my class at FDIC. And since then, we've become good friends. A man that has extensive background in fire research, in testing, and this would be Dr. Michael Reick. Now, he's in a different part of the world, and he's coming to you. The next 2 gentlemen are coming from you from Germany. So, Dr. Reick, could you tell us a little bit about yourself, sir?
Yes, thank you. So, my name is Michael Reick. I'm a regional fire chief in the south part of Germany, serving the 2,500 volunteer firefighters in my county. And I started as a civil engineer in a firefighting and construction material research institute, but then I decided to go back to my love, and this is firefighting. So I made a 2 years training program as a career fire chief, and since about 19 years I'm in my county a regional fire chief, responsible for 250,000 people.
Oh, that's great. Now, Doctor, it has been rumored that you are one of the people or the individual that came up with the concept, invented the concept of the smoke curtain, the door curtain, as we are starting to adopt that device here in the United States. Would I be correct?
Yes, that's correct. Well, basically, it wasn't even me, it was my wife. I was in New Zealand for half a year in 2004. And made hundreds of calculations with smoke movements in buildings. And I always found that smoke is always leaving a door to a burning compartment to the upper part of the entrance door. And all of a sudden, my wife told me, after I was upset because I couldn't overcome this with the pressure of a fan or anything else. And my wife just told me, well, keep the upper part of the door closed. So I tried it with calculations, and I found that it really works. So I came up with this stupid idea of hanging a curtain.
And you know where I think it's really going to catch on in the United States, if I could just look in my crystal ball.
Yeah.
This is my department, your typical American fire department. Responds to a fire in an apartment building with an interior hallway, and the fire's on the 2nd floor. Fire burning out of the windows, sliding glass door. Perhaps there's a balcony. Our typical procedure is to advance, stretch a line up the stairs. If the door to the fire apartment is closed, we bleed our line, we float a line, we make sure everything's ready to go. We propped open the stairwell door for a hose line. We pop the door, we wedge the door, we fight the fire, and what have we done? We've taken a perfectly tenable hallway that has been completely smoke-free and turn a hallway and a stairway into a chimney. So I think that we're going to be, I can see where, and I've seen the videos. In fact, I shared one of them with you at FDIC. Now, one thing that we are doing a lot in the American Fire Service, Dr. Reick, is stairwell pressurization, either with our own portable fans or an installed smoke suppression control system, a stairway pressurization system. So what we're trying to do is create that pressure gradient to reduce the amount of smoke that goes from the hallway into the stairway. Additionally, we have what's called smoke towers, where you'll either have an open vestibule or a vestibule with a ductwork in it, or in South Florida, balconies, so the smoke does not follow you from the fire floor hallway back into the stairway. So we're going to be talking about flow path control a little bit later, but we'll do that after we introduce our other guest from Germany, Mr. Jan, sir.
Hello.
Yes, sir. You're on, man.
Yeah, my name is Jan Südmersen. I'm from Osnabrück, Germany, which is the northern part of Germany. Right now, I'm a battalion chief for 20 years right now. And yeah, it was 1992 as I went to the States for a 6-month turn. And at Miami-Dade, I crashed into a good-looking young captain at Station 2, and I stole some things of him and during the next day. So I can say we learned a lot from Miami-Dade or for the United States fire departments.
I know that you've been to the United States quite a few times. How old were you when the first time I think you were just a kid in college, I think, at the time.
Yeah, 21 the first day I saw Mr. Bill Gustin.
Yeah, and we've become great friends and network quite a bit. And it's great to see you, Jan. I understand you're coming back to the States here. Will it be this fall?
Yep, I try to.
Okay, well then, you're going to be welcome at Station 2. We'll get on the engine and run dozens and dozens of door-to-door socialized medicine calls, as we tend to do there at my firehouse at Station 2.
I hope so.
All right, well, fellas, we're gonna broach on our first subject here. You would have to be living under a rock the last month, the last 30 days, not to know there is a 500-pound gorilla in our room. And we're not really talking about it. And what it is just how serious a problem that not just the American Fire Service, but throughout the world, it's an international problem, and that is cladding on the facade of a high-rise building. What I'm speaking of in a very general sense is some type of plastic, could be polyethylene, sandwiched in between two sheets of aluminum. Now, the problem is when the plastic itself is combustible. Mike Dugan mentioned this last Humpday Hangout last month when we were just getting preliminary information about the fire in the UK. Mike Dugan, I believe that is that there is an airspace between the cladding itself and the spandrel beams and columns of the building, so that we basically have a small flue in behind the cladding. Is that correct, Mike? Unmute yourself, Mike.
I'm working on it, Bill. Sorry about that. Yes, in some of them, they are put off the wall. It depends on how they are constructed and what way they are set up. Okay, some of them are off the wall, some of them are attached to plates that go up with like a 2x4 backing them. Some of them go up on the wall. It depends on how they're put up, whether they're almost like freestanding on the outside and how much they want to move them. Because a lot of them, they want to take these things and they want to sculpt it to a certain way to give angles and everything. So they set it off the wall and leave an airspace on some of them.
I'm going to thank Phil Paff. He sent me a number of samples. We're going to leave name brands out of this, okay? It wouldn't do us any good. And none of us know the whole story. None of us. We are all students of this. But it goes to show you, I mean, I'm 39 years on Miami-Dade, and yet I need to know everything I know about, or everything I can know about this cladding. I want to thank my dear friend, Greg Havel. He's from Burlington, Wisconsin. He writes that excellent Construction Concerns in the fire engineering webpage. He told me, here's a sample. He says, but if you fire test it, Bill, don't hold it in your fingers. So great advice, great advice. Unless I guess I'm wearing gloves there, Greg. So thanks a lot. Hey, I'm going to admit this is not a big issue with my department. We see this on car dealerships, convenience stores, and gas stations. This is not widely used in my part of the world, in South Florida. So I'm going to pass it on to Rick Owen. Rick, do you have any experience with this? Is this an issue that you face in Australia?
Well, Bill, we had the neighbouring department had a fire in November of 2014 called the lacrosse fire, like the sport. So you can Google it. But it was a 23-storey building which had it as part of the balcony, as part of the guardrail system, and it started on the 8th floor and ran to the 21st floor in a matter of minutes. It made a classic teardrop up the side of the building, but they couldn't do much about it. There was a bit of damage inside. The building was sprinkled, so that was okay, but hard to access, but it burnt exceptionally quick. And to this day, they still haven't remedied the problem on the building. They're in court, litigation, probably a byproduct of the US legal system.
Rick, when you say a teardrop, do I gather you mean that you had dripping, flaming, almost a running spill fire down the side of the building?
Yeah, and almost it made that perfect teardrop shape. You know, it was very long and narrow, didn't have much lateral spread, and just went vertical basically. There's some exceptional photos on the internet. But yeah, that's the only experience I've had in reading, and it's close to home. I live nearby, so I had a look, being a sticky beak as usual.
Rick, is there your department or is the Australian Fire Service taking any measures of thinking outside the box in terms of applying exterior streams to these cladding fires? Because I'll be honest with you, the American Fire Service, we are inept. You know, we are aggressive interior firefighters throughout the United States, and we are big advocates of sprinkler systems, and we are advocates of a protect in place strategy. But what did we learn from the Grenfell Towers? You can't protect in place when every apartment is being threatened by a fire that is spreading on the building's interior, and the sprinklers are practically useless.
The issue we're in a performance building phase where people don't have to build to the building code. They can have alternative solutions, and this is one of the buildings had an alternative solution, and they had actually deleted some external sprinklers and wall wetting systems on the building, and traded off distance of travel and stuff like that. But we're probably the same. We're behind the 8 ball. We're chasing ourselves. It's a concerning thing because we get a lot of it in, up to 10-story buildings. Our ladders or our aerial appliances reach that, but it's too quick for us. They burn too quick.
You and me both, brother. You and me both. Phil Paff, how about in your region of Australia?
Yeah, thanks, Bill. The situation in our state is, because we're a state-based fire service, is we've actually commenced an audit now to try and identify and locate these structures throughout the state. Number of our prominent facilities, namely a couple of hospitals, are actually clad in this material. The material is being tested as we speak, and in the interim, we've actually just upgraded our response so that we get more rigs to the job if it occurs. But as far as controlling the issue, should it happen, unless you have a system that's fitted externally prior, yeah, you're behind the 8 ball the minute you hit the rig. So You go.
It is. Well, no, I think we're all at a loss. I think we're all at a loss. I mean, I would like one of us, or like someone in the world, to stand up and say, "Hey, I have the solution." You know, maybe it's the Swedes. I don't know. They have this. I alluded to it in the previous month's hangout. I mean, I'm looking at some type of system that can have water cascade down the side of the building. Until we come up with something like that, we are indeed behind the 8 ball. Mike, any thoughts, any reflections, any experience that you have with this type of cladding and with the FDNY?
With the FDNY, in the fire code in New York City, the cladding has to be above the 4th story, has to be a fire resistive cladding above the 4th floor. So we can have buildings up to 4 stories, but we can get water on that quickly, especially with our tower ladders and master streams. We are using solid tips, so we do get a lot of water out of them. Unfortunately, a lot of our friends in different parts of the world are using diffused tips because their water, they don't have as much water. Some of the places are using smaller mains. We are going to flow water on this if it's a 4-story or less building. Above 4 stories, we're pretty good. We're still looking at some of the different things that we see here. But the issue with this is going to be, I think, in the building industry, where the fire resistive or fire rated cladding is more expensive. And unfortunately, in a lot of places in the world, they allow the building owners, the people building, to self-certify that they used the right stuff. And that is just it's a recipe for disaster, because they can save $5,000, $10,000, $15,000, which isn't that much money. But now if they go over on something else, they have this money in the background to kind of push, so they're not going over budget. They're protecting themselves.
Phil, if I could just, before we go on to Dr. Reick, I think you said that you have performance-based codes. And would you please, could you explain, Phil, in terms of Australia, I'm sure it applies here, the difference between performance and prescriptive-based codes?
Okay, Bill. Well, the situation as it stands is we do have a building code that is very prescriptive. However, as Rick was saying before, we're now in a time where if a developer or a construction company, they hire a fire engineer, they can provide you an alternative measure. So if they can demonstrate that they can achieve a similar level of safety by not being prescriptive as the code says, well, then we allow that to go through. The other situation is the term's called deemed to satisfy. So if you have, say, a panel as a cladding in this instance, and you apply that to the building, well, they can say, well, it's not combustible. Whereas the fact is in isolation, it may not be, but if you stack it end on end over 20 or 30 stories, well, then that's going to be a different issue altogether. I think the saving grace for you guys in the United States particularly is you have NFPA 285, and NFPA 285 is the full-scale facade test that you actually have to do a burn outdoors, or in a facility over a large area. In Australia, we don't have that. We don't have that situation. It's so narrow-minded to the point where our standard states that the core of a panel in this instance mustn't be combustible. So you can test the core on its own and the rest of it doesn't matter. So that's where we're at this stage.
All right. Thanks, Phil. Before we continue with our next 2 participants, I want to give a good shout out to our sponsor, Key Hose. That's keyfire.com. We recently received 7 new sections of Key Combat Ready, which is the top of their line. Hey guys, we all have a tendency to gripe about certain things that irritate us on our departments. But one thing I am very proud of is that the Miami-Dade Fire Rescue Department equips its fire companies with the finest, I believe, is the finest fire hose that money can buy, and that is the Key Combat Ready. I want to caution you, if you're shopping for hose, watch out for the criteria of, oh, it's lightweight, oh, and it packs real compactly for hose bundles and in your hose beds. Because you're probably sacrificing durability and heat resistance for mass that gives it that durability and heat resistance. We made that mistake about 30 years ago. We bought a particular brand. Wasn't made in the United States. Man, you could pack it so easy, it folded paper thin. But you drag it over the top of a chain link fence or get it in contact with a hot metal surface, and it's gone. So be real careful about manufacturers' claims that it folds very compactly and it's very easy and lightweight to handle. You may be substituting durability. You can't go wrong with the Key. If you can't afford the Combat Ready, they're top of the line. They have other grades that are also excellent, excellent. All right, having said, let's go on to Dr. Mike from Germany. And of all of us, he would probably be the most qualified to discuss testing and experience with this cladding. Go ahead, Dr. Mike.
Okay. I worked a couple of years before I joined the fire department in the fire research laboratory, and we did testings on material, construction material, load-bearing material, and also finishing materials. And if you test floorings, for example, or something on walls, it's totally different. And the main question with all these testing methods is your design file you use at the tests accordance to the real world? And oftentimes I made the experience that designers of manufacturers, they produce their products exactly to fit the test method. And if it fulfills everything the test strength wants from it, then it's fine, because then you can produce it cheap on the market. But the problem is, if the real world is only a couple of % stronger than your test material, sometimes everything fails totally. And this is the problem, like also with testing facades in Germany. We use a couple of inch thick polystyrene facades, and the testing design fire is a window that is broken, and you have a fully developed room fire, and the flames go out to the exterior of the wall. If everything is okay and the gypsum above the polystyrene is still okay, then everything looks just fine. But if your fire is a few % stronger and it destroys the gypsum, the whole polystyrene is open, and then all of a sudden you get a really huge fire. So the problem with testing is always if reality fits and knows how you tested your material.
Now, I've heard this rumor, and it's almost hard for me to believe it, doctor, that there are cases where the cladding is tested horizontally rather than vertically. Is that the case? Is that possibly true? Could that possibly be the case?
I can tell you for Germany or Europe that it's not the case. Like, we have to test material the way it is installed in practice. And if you want to install things on facades, you have to test them vertically and not horizontally, because the horizontal fire spread is a high number of times smaller than if it's going vertically. Therefore, it's totally different, and you have to test it vertically. We on our facades even have to have fire barriers on every floor level. So there are a lot of prescriptions, and if we can't reach the thing with our aerial ladders, so it's above 22 meters or 70 feet, then it has to be non-combustible.
Now, what do you mean by fire barriers, doctor?
Okay, if you have an air gap between the cladding, which is for weather protection, and your insulation, which is the shaft where temperature and fire can travel very fast, then you have to have a barrier in an opening inside your facade material. Other than if you have polystyrene or combustible facades, then every couple of stories or at the bottom, because we only don't look at fires that come from a window, there might also be a car or a garbage bin in front of the building, and it shouldn't light the facade. So we have to use non-combustible insulation on some parts on a facade and even every couple of floors to avoid a fire spread over the whole facade very far.
Well, that obviously was not the case in the Grenfell Towers in the UK.
Yeah.
Like I say, the verdict is still out on a lot of that, and nobody knows all the facts. Well, thanks, Dr. Mike, for your insight. Jan, any experience with cladding? Any thoughts?
Well,
reflections, opinions?
Well, they done some research in Germany, and they found out that since 2012 we had 90 fires with this cladding, and we had 11 deaths on it and over 100 injured people, but mostly above the fire, not on the fire floor. Me personally, I only had minor incidents with this cladding, but the problem that we often come to is that the German fire service is not generally giving large caliber streams or not having deck guns. They mostly attack a fire with, I would say, 100 or 200 liters per minute. And if they arrive on the scene where you have fire on the full facade, the most German fire departments would have a little problem to get enough water in a sufficient flow on this fire. So yeah, it's a challenge for the German fire service also.
I know I'm jumping ahead of myself, Jan. You know, we're kind of spoiled. We're fat, dumb, and happy in the United States with the size of our water mains. You know that.
Yeah.
And we can throw a lot of water in the United States. And our tactics are predicated on high flow, giving a fire a real punch. Again, I don't want to get ahead of myself because we are going to take a video, look at a video. I'm going to ask Phil. This has been provided by Phil, but it is available on YouTube. Phil, if you would narrate this for us, give us a little background. And Shannon, can you go ahead and roll the video? We'll give Shannon a minute. Okay, looks like we're getting it. Looks like we're getting some type of result here. All right. All right, you're going to have to enlarge that screen, Shannon. Okay, you got to make it bigger. That's all, and it'll be fine. All you got. Well, I think it's pretty big for the audience. I don't think.
If they click on it, Bill, if they click on it, it will light up. If you click on it,
okay.
If you click on that, it will bring it up.
Okay, great. Okay, everybody click on it. All of our participants. Phil, would you be able to narrate it?
Okay, Bill, what we got is we've got a particular brand of composite panel. The panel on the left is a fire resistive panel, and the panel on your right is your polyethylene panel. The only difference between the two is the amount of mineral core that is added to the polyethylene, and that makes it more fire resistive. There's just less plastic in the core. Essentially what you have is a test of replicating more or less NFPA 285, and you can see the extension on the panel on the right hand side there. It's marching up the side of that internal corner quite hard, whereas on the left hand side the fire burns to its maximum intensity and then it'll start to decline. Yeah, look around about the 7-minute mark, and the difference is quite obvious. What we don't take into account here is, as Mike Dugan was saying, is that cavity that exists possibly behind the panel, where you can have internal flame travel behind the panel unobserved to the external crews. There we go. What are we? 15 minutes. Yeah, and it's gone. It's gone. What we don't account for in this instance either is the amount of drop down that we could get into the street or into the lower areas of the building as well. And I think Rick Owen, you were saying that that was a similar situation to the Forte building in Melbourne.
Yeah, and the travel behind the panel and against the facade of the building doesn't allow us any opportunity to put water on it. That's one of the issues we had, or what they had.
And I think one of the other issues, brothers, is if the stuff is boxed into the windows, to now put the windows in the frame, it is almost automatically like a channel. If they bend it on some of them, I have seen them do it. Now I've seen them do it on with the fire resistive, but where they box it in and then they will have the corner piece and then the window will go in this opening. But now it goes in far enough to it's now inside the apartment. And I think, I don't know this for a fact, and I'm just surmising, this might have been what happened at Grenfell Towers, that they boxed it back in to the window frames. And now it led right into every window. Even the unopened windows got in there and got the flame spread because they put the windows now inside this as they boxed it in.
Okay, we're going to switch gears right now. And this is a question that it's certainly one that I have. And then as I talk and network with firefighters around this country, as I said, American firefighters are pretty fat, dumb, and happy when it comes to the size of our water mains. I mean, it's in my jurisdiction, if we have something smaller than an 8-inch main, that's oh boy, that's a cause for alarm. Or avoid that. But I realize that is not the case in other parts of the world. Reick, could you explain your water supply system and then how your tactics in terms of water application, liters per minute, gallons per minute, for you would be liters per minute, how you adapt to if there is indeed a limited water supply in your region? Unmute, Reick. That's
better, isn't it? Yeah,
sorry. Go ahead.
So a lot of our water supply, I'm blessed as well. I've got some good water. It's all gravity fed from dams in the hills. So I've got exceptional pressure. I can have, for you, I can have 100 PSI in the main, up to 150 PSI. So you may use the engine actually to slow the water down a bit because the velocity is quite high. But when we get into residential area, we go down to a 4-inch main, and that can be problematic some days. So consequently, probably the tactic we have is hit it hard fast. So I'd rather run out of water having a big go than just play around with 50 gallons or 200 litres a minute. Probably the tactic is give it a good shot early on to try slow it down. And it probably comes back to some of the Governor Island testing where you show give it a good hit and it cools it down, it makes the tenability better for the occupant. But we struggle a little bit on our fringe areas where we get out into the countryside and the interface areas between urban and rural and the bush. We start to run tankers then. We run tanker shuttles or relays. But where I am, I'm blessed with water. I'm quite happy.
Reick, a few years ago, there was a horrible loss of life in your country in a wildland interface fire. And I don't think a lot of our American audience understands that we think of our West Coast, California, Arizona, but you have equally as big a problem. Would you talk just a little bit about your fuels?
Yep, so
go ahead.
So we have, for us, we have the northern winds, which comes out of central Australia and heats everything up. So on the day in in 2009, we lost 173 civilians in a day or over a few days in fires. We had forward rates of spread in the grass of 70 miles an hour, so we couldn't keep up with it. The aerial helicopters couldn't keep up. But we can get 28 to 30 tonnes a hectare of fuel, and a lot of it's eucalyptus. And if you understand eucalyptus, it's got an oil which is combustible, and as we get up into the high temperatures, and on those days there's 110 Fahrenheit and about 5% humidity, it's a good day for fire. And with 60-mile-an-hour winds, we were chasing it. We've gone into so much now. You said about protecting place. Ours is about community warnings and engagement first. We want to predict where the fire is going. to give those people a heads up, because it runs so quickly. It can be from town to town, especially on the interface. And I think Phil has much the same issue up his way.
Phil, I want you to talk about that, but also before that, tell us about your water supply in terms of its limitations and how you've adapted your tactics if indeed it is limited.
Bill, very much similar situation to Reick is in the suburbs, we run around about a 4-inch main, and around the urban areas in the downtown is we're getting anywhere up, say, to a 10 or a 12-inch main. That's it. Similarly, the challenge we get is we have to do like relays. We'll stage rigs, streets and streets away just to be able to pull enough water out of that main in order to extinguish a fire. We don't flow anywhere near the rates that you guys do in the States, just because we don't have it there available to us most of the time. Bushfire stuff is Reick. They're up against it down there. Their countryside is a little bit different to us up here in the north, and swiftwater rescue. That's our big thing up here, up near the tropics. So yeah, very similar, but different at the same time.
All right, Mike.
Mexicans.
God knows that the FDNY knows how to throw water, and you do a pretty good job of it. And if there's anybody that leads the fire service in research into water application, it is the FDNY. I believe it was Reick. Did you allude to Governor's Island, or was it Phil? I can't remember.
Yeah, it's me, Bill.
All right, Reick, or Captain Mike, what did the FDNY learn from their water application tests at Governor's Island?
Well, you first have to understand the FDNY and the water situation in New York, with so many people in New York. When I was first promoted to lieutenant, I was UFO. In New York City terms, that's not an unidentified flying object, as Phil would think it is. It's until further orders. You're in a firehouse until further orders. And I was UFO in 207, the Maxi Water Unit, which used to be the super pumper. And we had water district maps of the whole city of New York by borough. And anytime there was a second alarm fire, you had to get up and find out where the nearest main was, and they had to be over 36 inches. We had mains on special hydrants that were 48 inches. We went up to 64-inch mains. And we had double hydrants for the Maxi Water Unit that you could get. The only thing slowing you down is the size of the hydrant. And we can get some of them. We have 6,000-gallon pumpers coming in now that were 6,000 GPM, gallons per minute, on these pumpers to pump to some of these buildings. So water is never our problem. I mean, it can be our problem, unfortunately, in fires like on Black Sunday, where we had frozen water in our lines. But typically, we don't have water. We have found that, water does its job, but you have to get it to the seat of the fire, and you have to cool it. So we have adapted. Some of our things that we have done is we will hit a fire from outside. We will use the floor below nozzle. We have done that. I remember when I was a young fireman having a fire in a building called the Schaumburg Plaza, where 7 people died. The only way we put the fire out was go into the adjoining apartment, breach a wall, and put the nozzle through the wall, and the wind carried the water and put the fire out. We were using it a different way. We were going from an adjoining apartment. We couldn't make the door with 2.5s. We were getting our asses kicked. Okay, so water does its job, but you have to be able to get it to the seat of the fire. And in the old days, we would put 2 engine companies down a hallway, they'd get burnt. Give us 2 more engine companies, they'd get burnt. Give us 2 more engine companies, they'd get burnt. Now the fire has gone down enough to put itself, lessen the amount of thermal offing that it is doing, because the fuel load, it's using up its fuel supply. And we have learned that it's not that the 4th and 5th engine companies to try were tougher or better guys. It's that the fuel load went down. So you have to be able to get the water to the seat of the fire. And that's what we have to work on now.
And would you say, Mike, that it's all well and good to throw some water from the outside with a transitional attack, but you'll never completely get water to the seat of the fire until you get the line inside?
Bill, when I first went on the FDNY, I remember pulling up to buildings on fire, and the boss would say, stang it, hit it with the deck gun, knock it, you know, while we're stretching a line, we got to go in and cut a gate, we got to make a front hallway or something else, there's fire there, knock it down so we can go do our job. We've been doing it for years. Just because we gave it a name doesn't make it new, doesn't make it different, okay? You can call it, you know, I've heard these, the coward stick, throwing it from outside. Yeah, we can do this. It depends. And if you are only going to use one tactic in the fire service, you are going to get yourself or somebody else killed. As everyone here has said, we have to be students of the game and understand this and be willing to do it. If you're going to stretch a line to the back of the building to throw water in a window and not take the line into the front door to protect the rest of the people in there, then you're not doing them a service. If you can see the fire, can knock it down, if you don't have the personnel, and that's what you have to do, it's understood. That's good. It's a tactic, but no one tactic is going to ever work on every fire.
Dr. Reick, are you satisfied with the water available in your part of the world? And if not, what do your people do to maximize its effectiveness?
Well, we think we have enough water. Nevertheless, it's a factor less than Mike has in New York. So, but still, I think we're happy with it. There are large fires where you need a large amount of water. That's no doubt. And if you can't limit ventilation, then you have to deal with a fully ventilated large fire, and this needs a certain amount of water. Otherwise, you're just playing a game. But the problem, just Mike described, if you're just throwing in people and they get hurt because it's too hot atmosphere, we try to have access to the point of the fire to get water actually on the fire by going maybe through hot parts of a building. And if you want to cool them down and don't want to be in the hot part of the low part, you have to capture the situation. You have to stabilize the situation. You shouldn't allow hot gases to flow above your head against where you approach to the fire. You should be able to stop it. And if you are able to limit ventilation, like a 3 megawatt fire needs 1 cubic meter of air, the oxygen of 1 cubic meter of air per second. And if you are able to limit ventilation, then you are happy with much smaller amount of water and you can still do your job.
Understand. In other words, this is one of the criteria that we use, Doctor, for whether we're going to attack a line off of our booster tank at a house, single-family house fire or not. If the fire is through the roof, we're going to need a heck of a lot more water, Doctor, because we no longer have a roof to capture that steam and limit the ventilation.
Absolutely true.
Are we both on the same
Yes.
page here, kind of?
Yeah.
So, Doc, I mean, I don't want to put words in your mouth, but if you don't have an abundance of water, then we're going to have to control a different side of the fire triangle, which would be, in your terms, the ventilation, the air supply.
Yes, yes. I think ventilation is oftentimes not really addressed by fire departments. If you keep it out of your numbers, out of your randoms where you can actually have influence on, then you're trying to hit it always with the same thing. And I don't think that you should do that. In Germany, in Europe, we have maybe better possibilities to underventilate fires because our walls, our buildings are more made of masonry walls, concrete slabs. So for us, we have triple glasses. It's oftentimes that we only have 1 or 2 windows that might be broken, and you only have a few megawatt fire in the building, and then it's very much possible to really address it and attack it with a smaller line. And the smaller hose lines, in our opinion, are often sufficient, and you are there faster, you are more flexible, and you can be more even aggressive and more flexible on the fire ground. I totally agree that this is also a limited approach. I totally agree that if windows are open on a couple of sites and you have a wind-impacted fire, then it's hard to underventilate a fire. But we have examples or experience with basement fires that it's really a huge factor if you're able to keep down the ventilation, and it's much easier to address and attack even large basement fires if you also look at ventilation.
Doctor, this is where I think is going to be one of the most useful purposes for the curtain, the door curtain. We have homes in a different part of my jurisdiction, not in my district, that are huge. They're 5,500 square foot homes. They're huge. And there's a fire burning somewhere in this building. We have very, very almost airtight homes because of the energy conservation measures with the weather stripping, the insulation. Basically, the home is so tight that a fire can consume itself, drop down below, say, 18% oxygen, and the intensity of the fire is reduced to the point where we don't even have any smoke pushing out of the structure anymore, Doctor.
Yes, yes.
What's scary, Doc, is that when we open that door to advance a hose line and the smoke is a few inches off the floor and we don't know where that fire is, it begs the question, are we going to reach the seat of the fire with our hose line? Or is the oxygen going to beat us to the seat of the fire and cause a rapid intensification? Doesn't happen right away, but once it mixes in proportion, and that's the scary portion for us. And this is where door control, and to a greater extent, that curtain is going to, I think, I won't see it in my time on my department, but I definitely see that we will do it. And we are already, not department-wide, but I noticed there are companies that are starting to pay attention to door control. In other words, limiting the amount of oxygen that's flowing into the seat of the fire.
Well, door control can be something where you try to avoid smoke spread in the building. And if the smoke isn't allowed to spread, you're limiting the problem to a small volume and it's easier to handle the seat. So smoke spread control is one thing, and door control for the reason to underventilate the fire is another thing. But if you tell people to close the door, even if the fire was already developed, or you use curtains very efficiently, then you also have to tell them how to fight underventilated fires. And you shouldn't allow oxygen to flow in and underventilate and then go inside and have the danger that maybe a window breaks. There are some limitations, there are some dangers you have to be aware of.
I hear you 100%. I hear you that you're going into an underventilated fire and a window should fail, or we have uncoordinated horizontal ventilation. Somebody breaks glass at, say, the Charlie side, and our underventilated fire, our ventilation limited fire, within a few seconds, anywhere from 100 to 200 seconds, depending upon the size of the structure, intensifies with fire over our head and behind us. And that's one of our biggest fears.
Yeah, you're true. But if a window opens and you have windows open on both sides, you get a substantial flow through the whole fire burning compartment. If only one opening opens on one side, it's normally only a fire problem, a fire development close to this opening where oxygen flows into the building and smoke is meeting and mixing with the oxygen.
Yeah, understand. Chief Jan, are you satisfied with your water supply, and how do you adapt your tactics if you're not?
Well, in my area, we got two problems right now. The first one is that the diameters of the water lines, of the hydrant lines, getting smaller and smaller. Right now we have 80 millimeters, and in our new building areas we're going down to 50 millimeters. That's because the water company says if you have bigger lines, bigger water lines, you have standing water, and then you have some kind of hygiene problems. So yeah, the water lines getting smaller and smaller, and that's one kind of reaction that we have, is that we bring water with us with big tankers. And the other kind of reaction is that we had a fire a year ago in a big recycling plant, and the water company asked us to take water from open sources very quickly. We started the attack with the hydrant water, but as soon as possible they wanted from us that we switch over to an open water source, a canal in the close by. We bought therefore a maxi water unit a few years ago. I guess it's the same like the FDNY has this Holland fire system, which has let's say supply lines which are normal to you, but which are very big for us. And yeah, so this is the big thing. The other thing is that the water company wants from us that we separate the water intake. There was an incident where the fire department pumped millions of water and foam, into the public water system. So they had to shut down the water system and to clean everything. So that right now they want from us to separate the incoming water to prevent get it pumped back into the water system.
No, Jan, we've got a cardinal rule here that we're not supposed to, either a building's fire pump or our pump, we're not supposed to drop down below 20 psi residual pressure. The more water we take out of the main, because if we drop the pressure too much in the water main, there's a greater chance of contaminants coming in. Now, 20 psi would be what? That'd be 5 bar. Would that be about right? 5 bar?
Guess so.
You guess so? Man, I thought you were the expert in this.
No, about 1.5 bar.
I don't know if it's right or not.
Well, the water pressure in our system is at least 1.5 bars if it's very low. But nobody really takes care of it at the fire scene. So it's very hard for us to tell if you got enough incoming pressure or if you fall down a special level of it.
I want to touch on something that Rick Owen said. He says you hit it hard first with your tank water. Is that right, Rick?
Yeah, we try to. Yep.
There seems to be a paranoia in the fire service, at least on my job, about running out of tank water. Brothers, we're not fighting a Class B fire here. It's not like we're hitting a flammable liquid with foam. You don't have to completely flip the fire out with your tank water. You're going to take the energy away by mass application of water. In our terms, rather than apply 1,000 gallons at 100 gallons per minute, why don't we apply that 1,000 gallons in 2 minutes at 500 gallons a minute? Will we completely put the fire out? No, but it's going to take quite some time for that fire to redevelop into its original size. So maybe we're better off with a greater application and knock the fire down, and then we'll secure another source of water. We could go on all afternoon, except I think our friends in Australia are going to what time is it there now, fellas, in Australia?
4 in the morning.
Oh, you guys got to get up and go to work here, man. What time is it, Jan? Jan, what time is it in Germany?
It's 8 o'clock in the evening.
Oh, okay. I think we're going to have to go out and have a couple of, how do you folks say, liquid bread.
Here we go.
Yes.
You want to know something? Beck's beer isn't even made in Germany anymore. Beck's made in St. Louis. Now, there's just something really wrong. Now, big lawsuit. Oh, my God. Well, cat's out of the bag now. Fellas, we're just about at our time. The respect that I have for you fellas, the respect that I have for you fellas, the commitment that you make to come to FDIC almost every year is just remarkable. And you are setting a huge example for not only your country's fire service, but fire service, our friends all over the world. And fellas and ladies, you're watching. This is the type of thing. Fire service is a community, it's a brotherhood, it's a sisterhood, and collectively, we're going to come up with some type of solution to this problem because it's a problem worldwide. Thank you so much for participating from Australia and Germany. God bless everybody around the world, and may He keep our brother and sister firefighters safe.
Thanks for the opportunity.
We'd also like to thank Key Hose for sponsoring this. One more time, Key Hose. We appreciate them doing this for us. So thank you, Key Hose. And we will see you next month. Thank you.